Okay. So you should have picked up Unit 6 over there, note packet and homework packet. So let's put the homework packet away at this time so that we can focus in on the notes and all that fun stuff and just have that note packet out. So if you didn't finish or if you didn't take the test from yesterday, that's waiting for you in the resource center. Let's make sure we get it done ASAP. Okay? Yeah, and then we'll have some homework tonight, and all will be well. All right. So this is page 2 of your notes. Obviously, page 1 was the title page. Okay. So here we go. Can anybody refresh my memory as to what the Pythagorean theorem is? It is probably the most well-known and popular theorem of math that there is. Anybody remember? It's exactly a squared plus b squared equals c squared. That is the Pythagorean theorem. Now, a couple of things about the Pythagorean theorem, just to refresh your memory. Okay? First thing is, you have to have a right triangle. Okay? The Pythagorean theorem only works on a right triangle. Okay? So, if you don't have a right triangle, you can't use a squared plus b squared equals c squared. Okay? That's thing number 1. Thing number 2 is a and b are interchangeable, okay? And they're what are called the legs of the right triangle, okay? So those, it doesn't matter which one you put as A, which one you put as B, okay? Okay? Your neighbor might put the opposite ones as A and B, and that's fine too, okay? The third thing is that C here is the hypotenuse. It is the longest side and it is always across the triangle from the right angle. Okay? So that C will always be across the triangle from the right angle. Okay? So let's put it to work then. So a squared plus b squared equals c squared. Here we've got a right triangle that's signified by this right here. Okay? We've got a side that could be A. If that's A, then that's B. If you wanted to make A be 4 and B be 3, that's fine too. But what we're missing here is we are missing side C. We're missing the hypotenuse of the triangle. So we're missing that side. So we could go setting up a squared plus b squared equals c squared. So then that would be a would be 3 squared. B would be 4 squared. And that's going to be equal to c squared. 3 squared. Anybody? 3 squared. 9. 3 times 3 is 9. Okay. 4 squared. 16. So this is 9 plus 16. 9 plus 16. 25. Oh, tap the brakes. We're jumping here. And how am I going to solve 25 equals c squared for c?
Whatever two things multiply each other to 25 with the same number.
Okay.
So if it's like 5 times 5 is 25.
Okay. Do you know what you just described the process? Do you know what we call that process? No? Anybody? I saw his hand first. Square root. Is that what you were going to say, Lily? Couldn't see his hand. I could though. Square root? Yep, so we're going to take the square root of both sides. Yep. Okay, and the square root of 25 is 5, and the square root of c squared is c, so our missing side length there is 5. 4 is what in the middle one? What is 4? B. Okay. All right. What is 7 then? That's C because it's opposite the right angle. Okay, so that one's got to be C. So my a squared plus b squared, now in this one I'm going to be looking for a. Four squared? 16. 7 squared?
49.
How am I going to solve that one for a? Subtract 16 from both sides. 49 minus 16. 33. I've got a squared, but I want a. How do I solve that for a? Square root. Okay. Square root of a squared. Left side, square root of a squared. A. Square root of 33. Ooh, no, we can get it exact. Square root of 33. That's rounded. I want it exact. Still rounded. Mm-hmm. Nope. Trick question.
No solution.
Nope, there's a solution. If I don't want you to use a calculator, what would the square root of 33 be?
Oh. 33 or 33 over a.
Nope. Got it? Nope. I want it exact.
Square root of 33.
Square root of 33. Can I simplify the square root of 33 at all? No, because there's no perfect square factors that go into it. Remember we did that first semester? We did some simplifying of radicals. Okay? So it's just the square root of 33. It's kind of like, ladies and gentlemen, when I told you, leave stuff in fraction form. It's less work. Okay? If you put stuff in fraction form and leave it, you're done. If you want to get a decimal approximation, now you got to go to these stinking calculators and you got to type it in. Okay? If I've got the square root of 33, leave it as the square root of 33. Okay? It's less work. Okay? So nobody should really have out a calculator right now because we're not going to use them. Okay? Now in this next one, we might use them because we have big numbers. Okay? We might use them for that, but we're not going to use them for our answers. Okay? All right? So you try here now that third one. Find me the missing side on that right triangle. I get A is 15 on that one. Or B if you chose B for this. But it's either A or B there. The missing side length is 15. What did I say about homework packets? All right. So, we are moving away from algebra and into some more geometric concepts now, second semester. Okay? All right? So, one of the things that we have to talk about is we have to talk about transformations here in geometry. And there are three main types of transformations. Okay? There's reflections, where it's kind of like you look in a mirror. Okay, that's you seeing your reflection. So that would be when you look in the mirror, you're seeing yourself, and you're seeing it in 3 dimensions on that far away. So you're reflecting it over that line, and that line is the mirror. Okay? There's transformations, where you're just going to take an object and you're going to slide it horizontally or slide it vertically or both. Okay? And then there's rotations, where you take an object and you spin it around a specific point. Okay? Okay? So let's talk about reflection first, because that's what we've got here going on. Okay? So here in letter A, we want to reflect the rectangle over the x-axis. Okay? So the x-axis is this axis down here. So I want to reflect that in it. So I'm going to take this point right here, and it is 1 up from the x-axis. So that means I've got to go 1 down from the x-axis. Okay? This point right here is 4 up from the x-axis, so I have to go 4 down from the x-axis. This point right here was 1 up from the x-axis. This point right here was 4 up from the x-axis. So there is my rectangle right there. And we would call that A prime, because we reflected it 1 time, so we would call it A prime. It's not the original. The original's name was A. It's the new one, so that's why we call it A prime. Okay? If I'm reflecting it in the y-axis, do this one in a different color now. Now I'm looking at this as the blue line here as my line of reflection. So now this point here was 2 to the right of the y-axis. So I'm going to go 2 to the left of the y-axis. This one here was 6. So I got to go 6 left. Six left, 2 left. So there now would be my rectangle. got to draw your line, and then you've got to find distances to it. Okay? And those distances are always, how you reflect, you always reflect it perpendicular to whatever your line of reflection is. Okay. Page 2. All right. We'll skip the word part. We'll go right down here to reflections, okay? So, we'll do number 1 together, and then I want you to do the remaining 5 here now, okay? So, the dashed line is my line of reflection, okay? The image is written there. We want to find the reflected image. So, if I'm going with this point right here, that is 1 to the left of my line of reflection. So on that same horizontal, I would go 1 to the right of my reflection. Two to the left, 2 to the right. And then you can connect those two because those two dots are connected. 1 more. Down 1. And you're kind of filling in that as we're going along. And you're going 1 out. Then you're coming down 1. In 1. Down 2. Right 1. And then there we go. And there's the image reflected. Okay? You now reflect the other 5 images. Agree with me on that first one? Straight down, okay? What's up? No. I'm good. I just gotta get through and do it, you know what I mean? I gotta pick up. Oops. Come on back to me now. So.
This was the hardest one.
This one? Mm-hmm. And then 1, 2, so that's there. 1, 2.5. 1, 2, right there. So where's my long side? There we go. Yeah, there we go. Yep. Here, here, and there. So it should look like that. There's that one. There's that one. What about number 6? You left it? Well, this one would have to go 2 over this way, so it would go there, right? This one would have to go 3 over, so that would go there. This one would have to go 2 over, so it would go there. This one would have to go 2 over, so it would go there. This one would have to go 3 over, so it's there. It's going to end up being the same thing. It's going to end up being the same thing. Yeah. All right. Questions on any one of those? Fix them now if you didn't get them right. All right. Now, things may look like a reflection when it really isn't. So in number 1, okay, so it's saying what this dashed line with the arrow on it, okay, it's saying, is that truly a reflection? Okay, and you got to use your mind here now to see if that is a reflection or not. Would you agree that it is a reflection in number 1? Yeah? Okay. I would agree that this would be a reflection. Okay. What about number 2? Is number 2 a reflection? No, it's kind of rotated, right? Because we took this left one, and we spun it around a point and it ended up there. So I would say no here. This is a rotation. Yeah. What about 3? Is 3 a reflection? Why not? It's easy. It'd be upside down, right? Yeah, exactly. It would be upside down if it was a reflection. Okay? So this one is a no. This is actually what's called a translation. Okay? You just moved it. Okay? What about 4? Reflection, not a reflection. You think so? You think? What do we think? Reflection, not a reflection here in number 4. So if it were a reflection, I suppose they're not really parallel. As I say, that line would have to be pretty close to being parallel, right? So then this one would come down and it would be like right in there, right? And then the heart would be up here. You understand what I'm saying? Like, I mean, it's tough to say. I don't know. Jury's out. Yes or no? Yeah? What is the easiest one for it to be? Because they can be both. You can have reflections and translations and rotation all in one. What would the easiest one to say this would be? Just a rotation, right? Okay, just a rotation. Yeah? So that one's kind of that's a tricky one. That was a little stumper. Okay? All right, so now what I want you to do is I want to talk a little bit about your homework, because that's why I didn't have you do it from the start, because I had to explain stuff to you. Okay? You are going to, one, leave your answers in simplest radical form. Okay? So you're going to simplify your radicals. Okay? I'm looking here at number 4. And at number 4, I want to go 3 squared plus, we'll call it b squared, equals the square root of 10 squared. What happens when you square a square root? So it just goes, so what would the square root of 10 squared be? It would just be 10, okay? A squared cancels out a square root. So this would just be 10, not 10 squared, just 10. Okay? Bless you. So many times, bless you. Okay? One more that I wanted to talk about. Oh, on these. It is asking you to reflect this one. Okay? So on number 9 here, instead of reflecting the ant, okay, just pick the 4 corners of the ant and reflect that over the line. Then if you want to draw the ant in after that, then you can. But reflect the corners of the ant first, and then just do it. Okay? Good time.